All right, friends, we're going to deal with graphing radical functions. We're going to work off of translations. So we have talked about things this year like x minus 2 squared minus 5, and how this minus 2 on the inside is going to move us left and right. It's going to be opposite. So this is going to tell me to move right 5, and this tells me to go down 5 because the outside is up and down. It's true. So that's exactly what's going to happen here. We also dealt with putting a coefficient in front of the whole thing, making it a stretch versus a compression. So we're going to stretch for things that are greater than 1 and a compression for things that are less than 1. We have an x-axis reflection that makes things upside down. So you can see all those things are going to tie in here. So the only thing we really have to do is identify what is the shape. So when we deal with our square root, we'll deal with that first. All right, the square root of 0 is 0, square root of 1 is 1. 2 comes from the square root of 4. Okay, so we start to see kind of the sideways parabola. I can't do a negative, right? So I don't get anything down here. Like this part of the parabola doesn't happen. I just put it in because I want you to see what it looks like. So we get those. When we go to our cube root, I can do the cube root of a negative. So what happens is I get the left-hand side of this for our cube root. So those are the two functions we're going to really focus on today. So let's take a look at it by doing some of them. Here we go, domain and range. All right, so inside of here, we're going to go to the right 3. 1, 2, 3, but it's also up 5. So 1, 2, 3, 1, 2, 3, 4, 5. My a value is 1. Right, so I'm going to go up 1 and over 1. That's enough to give me beginning of my shape, right? This is 3, 5, the ordered pair. That might be helpful as we talk about domain and range, right? So my domain, x is greater than or equal to 3. My range, y is also going up, so greater than or equal to 5. So that's why I wanted to write out the ordered pair, just because it makes it a little bit easier to see. Right, next one, here we go. Minus 1, minus 2, negative 1, negative 2. Right? Negative 1, negative 2, and negative's kind of hard to see there. It's still positive 1 out here, so I'm going to go up 1 and over 1 and start getting that arcing shape. So the domain, x is greater than or equal to negative 1. The range, y is greater than or equal to negative 2. All right, not too bad so far, right? All right, let's throw in an a value. See what we can do with these. So we know this is going to be right 2 and down 3, right 2, down 3. And then my a value is negative 2. So I'm going to go down 2 and over 1. So I get this type of arc. So same thing, we flipped it over the x-axis. So the domain definitely has to do with x is compared to 2. It's still going to the right, so it's greater than or equal to the range this time. Y is going down, is less than or equal to negative 3. Because this point does count, that 2, negative 3, it does count. X-axis reflection, and it's been stretched. It's a little bit taller than the normal one. That's why we went down 2 and over 1. Only going to work for the first point away. All right, let's focus in on the next one. I don't have anything inside of here, so I know it has to do with 0 and negative 3. So 0, negative 3. Right, so that's kind of the tricky thing, is when things begin missing, when there's 0 here. Negative 1/3, so I know it's upside down, so go down 1 and over 3, so really stretched out for that curve. So domain, x has to do with 0, it's going to the right, which is still greater than. The range, it's going down, which is less than negative 3. So that's our square root functions. We get a lot more active in our domain and range than we did with, say, quadratics, because these were mostly all real numbers for the domain. All right, cube root, all right, remember this one has to do with kind of the same thing we were dealing with, but also the left-hand side goes down. So where we're going to go? We're going to go left 1 and down 4. Left 1, 1, 2, 3, 4. All right, now I have a value of 2, so I'm going to go up 2 and over 1. Remember, the overall shape is supposed to still be that arc. I also get the left-hand side, so kind of like a little pinwheel here. All right, now I didn't continue with domain and range because, as you're going to see here, the domain goes left and right, all real numbers. The range goes up and down, all real numbers. So I'll state it this time, but then we're kind of maybe done with it. I don't know. It'll probably go in there, but just know that it's all real numbers. All right, last one of our cube roots. Maybe we should have had more of these. Well, we'll do more in class, if you're in my class. If not, hey, thanks for watching. This time I can put a +0 out here. So we're going to go right 2, and it doesn't go up or down. So right 2. Oh, wait a minute. It mixed it around. See how easy it is to get confused with that? This is a +3. This is up 3. So let's go right 2, up 3. Man, can't believe it did that. So embarrassed. All right, so my point is 2, 3. That's kind of our starting point. Now I'm going to use upside down, -1/2, so down 1 over 2. And we know it's a pinwheel action here. So that's our x-axis reflection, and it's been compressed. So I see it's kind of squished, and it's upside down instead of right side up. So we get all those things going. Again, if I talked about the domain, it would be all real numbers, the range, all real numbers. So no big deal with that. All right. So if we want to make some of these easier to graph, what we can do is rewrite it. So 31, let's just pull this out. 31. What I can do with my square root of 9 is, notice I have a GCF of 9. So I can do the square root of 9 and then x minus 1. But what is the square root of 9? So I can actually separate these as the square root of 9 and the square root of x minus 1. So it's 3 square root of x minus 1. So I see I have a vertical stretch of 3 and then an x minus 1. So that's all we're doing here. So I'll take 32 as well. So GCF of 16 and 32 is 16. So I'm going to do square root of 16 and then do the square root of x plus 2. Keep in mind there's a negative out here. So I'm going to go with -4 square root of x plus 2. So if we talked about what's happening here, I have an x-axis reflection. I have a vertical stretch of 4. And the last thing we have is a translation to the left 2. And now if there's already something out here, we would just multiply it by that, just like we did here with the -1. No big deal, right? I don't want this video to go too long. You guys like when the video is a little bit shorter. So let me get to the cube roots. So again, we just have to recognize what the cube root is. In this case, the GCF 64. I need the cube root of 64, and then it'd have x plus 2. So this is for 34. The cube root of 64 is 4. And then I have the cube root of x plus 2. So the two things going on here is we're going to move to the left 2, and we have a vertical stretch 4. All right. We have one more that I'll deal with. 35 real quick. Hang in there. 35. So what do we got? It's back to a square root. So 25. All right. Square root 25, square root of x plus 5, and then a -3. So it's 5 square root x plus 5, and then a -3. All right, so we can kind of walk through each step, right? We have vertical stretch. We're going to move it to the left 5. We're going to move it down 3. So just watch for cube roots and square roots. All right, so if you get really good at it, notice we're going to take an 8 out. So I might just call it 2 square root x minus 3, and then plus 1, and then walk through a vertical stretch of 2. We're going to move right 3 and up 1. So we get all. So we can alter those radicals by rewriting it, right? I'm not just making things up. I'm taking out a GCF. I'm separating those factors, right? I can't separate terms, but I can separate factors, and then working with it that way. So you do have 33 we didn't touch on if you want to try that. And I guess 36 we did. But that's it. We'll work on it in class. Unless you're not in my class, hopefully it helped.